Hello, my name is Swan Song. I will present our paper Active 3D Modeling via Online Multiview Stereo. 3D modeling of large-scale structures is an important issue. Multiview stereo methods are widely utilized for the 3D modeling because they can reconstruct long-range scenes. The multiview stereo is an offline method that processes a collection of images in a batch. In order to collect the images, most people commonly utilize the drone to pilot method. As can be seen in the figure, a drone automatically moves along a simple trajectory for scanning. However, this autopilot method does not consider the scene geometry of target structures, so they cannot scan occluded areas and produce an incomplete 3D model. To address this problem, the exploit and exploit method is recently proposed. This method first constructs a coarse model by scanning an entire scene using a simple trajectory. Then it plans an inspection path for the coarse model and performs a rescanning. However, the exploit and exploit method has some problems. First, initial and rescanning trajectories are frequently overlapped. Second, the multiview stereo does not guarantee an accurate reconstruction due to several factors such as textureless scene, short baseline distance, or occlusions. And the multiview stereo algorithm usually takes a long time to process images. To solve these problems, here we introduce a new method that utilizes an online multiview stereo system. Unlike the previous approaches, our method constructs a 3D model in real time and evaluates reconstruction quality. Then our method plans the exploration path using the reconstruction quality feedback. Therefore, we can construct the complete 3D model in one exploration trial without any rescanning trial. Let's talk about online multiview stereo. Instead of structure flow motion in conventional multiview stereo method, we use a slant method to estimate the camera pose. In this study, we employed the arrival slant. When a new keyframe is extracted, we estimate the depth map of the keyframe. We employ the remode method to estimate the depth map. The remode is a molecular depth estimation method based on a motion stereo. The estimated depth is relatively sparse and have many outliers. Therefore, we perform the post-processing for noise filtering and depth interpolation. Start from an initial depth estimate. We first apply the fast-weighted least square filter. We then extract the piecewise planar areas using the linear triangulation method. Finally, we obtain the refined depth map by applying the filtering result only to the planar areas. The estimated depth maps are integrated into a 3D surface model. We employ a surface-based mapping method. This video shows a demo of the surface mapping. The surface mapping method efficiently maintains the dense detailed geometric information of the large-scale point cloud. As shown in this video, it receives a pair of color image and depth map as an input and constructs a surface model online. Our system also processes the loop cruising when the slant mode performs the loop cruising. Our method individually transforms the position of each surface according to the updated pose graph. Therefore, we can preserve the global consistency with the slant model. Next, let's talk about the path planning method. Our method first determines the global path to explore the unknown regions. It computes the coverage path of the entire frontiers. We sequentially complete the entire modeling according to the coverage path. A global path is determined as the first path segment of the coverage path. Next, our method determines target surface that need to be scanned for high-quality surface modeling. Start from a surface model. We first predict a tentative surface model by using Poisson surface reconstruction. We define the confidence of a surface as an averaged surface weight. Then, we determine the target surface by clustering the low confidence surface. The next stage is local path planning. It first determines an inspection path that provides a full coverage of the target surface point. Then the inspection path is refined to maximize the performance of multiview stereo reconstruction. We define a gain function of a viewpoint for a target surface based on multiple heuristics, such as parallax, relative distance, and focus angle. Then our method finds an optimal path that maximizes the information gain while meeting a budget constraint. This problem can be solved by using the informative path planning algorithm. Here we have a demo video of our method and the latest exploit and exploit method. That is the submodular coverage path planning method. The method first constructs the course model using a simple circular trajectory. Then it performs a rescanning using a covered path of the course model. As you can see, it sometimes revisits the already passed route. On the other hand, our method can fully cover the entire surface without any prior information. The revisit or rescanning is not necessary for our method. So our method can efficiently complete the modeling and save exploration time. This figure shows reconstructed 3D models of each method and their trajectories. As can be seen, our method can reconstruct the clean and complete 3D models. This table shows the experimental result. Our method has the best modeling performance in terms of accuracy and completeness. Our methods focus on completing the poorly reconstructed surface online. It also optimizes the path based on the information gain of the multiple heuristic. These approaches improve the modeling performances. Furthermore, our method had the best path efficiency performance in terms of completion time and path length. So to summarize, we propose an online multiple stage system based on the monocular dense mapping and surface mapping method. We also propose a view path planning method that analyzes the reconstruction quality online. Our method can reconstruct the complete 3D model with one exploration trial without any rescanning trial like the exploit method. For future work, we'll test the proposed method in real-world environment. In this study, we assume that the estimated camera posts are reliable, but this assumption is not always valid in real-world applications. Therefore, we should consider the uncertainty of the localization for path planning. The application of active SLAM approaches to our method would be a good direction for future work. Thank you for your attention.